So this project is related to comparing of Bayesian and maximum likelihood estimation in state space model, called it in MATLAB simulation model. So in this article, basically I have just built the comparison of Bayesian and maximum likelihood estimation methods in the context of state space models with the focus of implementation in the MATLAB. Okay. So the state space model, basically these are the powerful tools for modeling of complex time series data, but estimating their parameters can be challenging. And the Bayesian estimation, which incorporates the prior knowledge into the estimation process, has gained the popularity in recent years due to its ability to provide more accurate and robust estimates. Okay, so in our case, I have used the state space model, which is basically a powerful tool for the time series analysis and which allow the estimation of underlying states and the parameters. So I have just written the complete abstract for the estimation tools for the Bayesian estimation. Basically, in the Bayesian estimation provides a more accurate estimates, especially in cases where prior knowledge is informative knowledge is informative, and while the maximum likelihood estimation can be computationally more efficient. Okay, so I have just written the keywords introduction, which in the introduction I have just explained how the further with Skinner scientist explained the finite mixture model and the Markov switching models for the complex dynamics. So after that, I have also added the Markov chain Monte Carlo technique for the estimation of parameters of state space models, demonstrated by the Carter and Kohn. Okay. So these are the maximum likelihood versus Bayesian estimation. And this graph displays the comparison of parameter estimation method. Okay. In this, I have just explained how state space model is a powerful tool for the time series analysis. Okay. And basically it uses the diffuse Kalman filter, which is useful technique for the handling of non-stationary time series data and estimating the parameters of state space models. So after that, I have just written how it is challenging to estimate in the state space model parameters according to the estimation of fast filtering with the smoothing algorithms, such as which is basically developed by Koopman and the Durbin. Okay, so next one is basically Bayesian estimation, which is a popular approach. I have just added how the Bayesian estimation approach is used in the MATLAB to estimate the state space model parameters, offering a flexible and robust framework for incorporating prior knowledge and uncertainty into the estimation process. Then maximum likelihood estimation, which is basically used the Markov chain Monte Carlo techniques, which describes by the cameraman and Lopes, and also it provide us the researchers and practitioners due to its simplicity and the ease of implementation. Basically, maximum likelihood estimation is the most popular choice because it is easy to implement in the MATLAB to get the output results for the classical approach of estimating of state space model parameters. Okay, then I have also compare the Bayesian and maximum likelihood estimation, which developed in the MATLAB. So after that, objective and scopes also added problem statement and methodology also added here, like what equations used in our case, like random walk and the process and the sum of net exports. These are the equations used in our model basically, and the goal of the is to estimate the unknown parameters, including the auto regressive coefficients. Okay, so I have added the table parameters as well, which is basically the parameters with this description and the values used in the MATLAB code. Okay, so these are the step-by-step approach how we can just initialize, how we can just do the true state space model representing the data generation process, then use of simulation smoother to draw a random path from the distribution of the second smooth state. Okay, so I have just added it everything, state space model components and estimation approach. Okay, zigzag estimation of state space model, then the design MATLAB simulation analysis according to the time space values as well as the autoregressive coefficients values. So these are the output results for the simulated net export series. Okay, so in which second one is trace plot for the five basically use the aggressive elements regressive element coefficient for the trace plot for yes sample autocorrelation function, which is basically for the autocorrelation plot for the regressive coefficient autoregressive coefficient. So these are the output results for the histogram of posterior distribution of phi with the simulation of mean, true mean, 95% confidence interval. Okay, see the 95% confidence interval represents the dotted line upper end in the model. So these are the comparison, and I have added the conclusion and references accordingly. Let me show you the output results for in terms of MATLAB. You just need to open this MATLAB function. Okay, so basically let me just add here close all. So basically it just clear the command window. This command will clear the workspace, and this command will clear the opened figures of MATLAB output results. Okay, so these are the state space model which I have developed in terms of different net exports in call. We also added simulation trace plot for phi. Then I have added the simulation mean, true mean, and 95% confidence interval as well. Run first. Let me see. These are the output results added in maximum likelihood. Okay, and then sample size, logarithmic likelihood, okay, key info criteria, Bayesian info criterion. Okay, these are the output results for the confidence interval with the standard error, with the time stat, with the probation, and with the coefficient of regression, autoregression. So the output results looks like this. Okay, figure 2. This is a figure 3 sample autocorrelation for function. Okay, and the final is the simulation mean, true mean, and 95% confidence interval. Okay, so if you need to ask anything, you just call me. I will answer your questions. Thank you.